cosine over 1 plus sine equals 1 minus sine over cosine. So none of these have any squared trig functions, so right off the bat we can't use any Pythagorean identities. And actually everything is already in terms of sine and cosine here, so we can't really use that strategy right off the bat. But this strategy is going to be to use a conjugate. What's a conjugate? What is a conjugate? Flip the sign when we're adding or subtracting. Yeah, so for example, the denominator of the term on the left here is 1 plus sine. The conjugate of that would be 1 minus sine. So one of our strategies is to multiply the numerator and denominator by a conjugate. So if we start with the left side of this equation, I'm going to multiply top and bottom by 1 minus sine. Minus sine. Right. The reason that we do that, so I'll write this one out as well. Is when I multiply out this denominator, so I'm going to leave the numerator factored. So cosine times 1 minus sine. When I multiply out the denominator here, we'll have 1 times 1 is 1. Then 1 times negative sine would be negative sine. Then sine times 1 would be plus sine. And then we'll have sine times negative sine would be negative sine squared. So what happens is the middle two terms cancel out. Right? We have negative sine and positive sine. That's always going to be the case when we multiply by a conjugate. Okay? That's why multiplying by a conjugate is a nice strategy. So now, in the denominator, I'm just left with 1 minus sine squared. Well, that's one of the manipulations of a Pythagorean identity that we just looked at. Right? If we know that one of our identities is sine squared plus cosine squared equals 1, well, I can subtract the sine squared over and have cosine squared equals 1 minus sine squared. So in the denominator here, I'm going to go ahead and erase this. We just have 1 minus sine squared. I can replace that with cosine squared. So we end up with cosine times 1 minus sine over cosine squared. Well, now I can cancel out one of these cosines. If I've got cosine over cosine squared, I can cancel out a cosine and just be left with 1 over cosine. Okay. So then, this just becomes 1 minus sine of x over cosine. That's what we want. I guess I should have been writing out the right side as we were going. Okay, so whenever we see something like this, it is probably going to be a good strategy to use a conjugate and multiply top and bottom by the conjugate, which will more than likely create a Pythagorean identity. Okay. Questions?
So, are you ever going to have us, or like, are you always going to specify what side to start on with the identity problems?
No. I mean, just like the ones in the book, and it'll just be something like this, and you can start on either side.
Could you get the conjugate of the one on the right side, which is the same thing?
Yeah, we could have done the same thing on this side. I could have multiplied over here by 1 plus sign over 1 plus sign. Then in my numerator, we would get 1 minus sine squared over cosine times 1 plus sine. We would have, then we could say 1 minus sine squared is cosine squared. So cosine squared over cosine times 1 plus sine. And then one of the cosines will cancel out. We get cosine over 1 plus sine. So yeah, we could have done it working with the right side here as well. Same process. All right. Other questions? Do you guys want to do another one like this together? Or do we think we can try some? Try some? All right. All right.